Hi everyone. So I am a person who scored 800 on the math section of the SAT with a 1560 composite score. And today I'm just going to go over 5 hard algebra problems from the SAT. So these are actually questions released by College Board. So it's pretty, as far as I can tell, they're pretty accurate to the actual exam. So these, you're probably going to see at least some of these problems on the actual exam, and I'm just going to go over them right now. So starting with the first question, in the given equation, s and r are constants and s is greater than 0. If the equation has infinitely many solutions, what is the value of s? So this is a linear systems problem. So essentially we have one line is equal to the other line. So this is line, so this is line 1 and this is line 2. And for two lines, for example, if I were to draw them like right here, you can either have lines that are parallel, which means that there's no solution, two lines that intersect, which means that they have one solution, and finally, two lines that are literally the same, so two lines that overlap with each other. So this is the case that has infinitely many solutions. So obviously, because there are infinitely many solutions, we know that the two lines here must be the same line. So let's see what we can get with that. Now, because the two lines are in our linear system, they are in the form of y is equal to mx plus b. So if two lines are the same, then their slope and y-intercepts, or their m and b are the same. So let's find, so you just basically have to find, equate the m and b of these two equations. So let me do that right here. So we have y is equal to, so this is for the left side, y is equal to 12x plus 28 over 4 minus s over 13. This is equal to, so if you divide the 4 for both of these, it's 3x plus 7 minus s over 13. And for the second equation, we have y is equal to r times x minus 8. And if we distribute the r in, then we have rx minus 8r. And because the y is equal to mx plus b, we have m1 must be equal to m2. So like these two m's must be the same, and the two b's have to be the same. So 3 must be equal to r, and minus 8r has to be equal to this part. So 7 minus s over 13. And if we plug in the r is equal to 3, we get 7 minus s is over 13 is equal to negative 24. Right. So we get s over 13 is equal to 31. And so s is equal to 13 times 31 is equal to 403. 403. For the function f cx is equal to x minus 8, okay, c is a positive constant. If f2 is equal to 35, what is the value of c? So we essentially just plug f2 is equal to 35. So here, cx, this part is equal to this. So cx has to be equal to 2, which means that x is equal to 2 over c. So we plug this x is equal to 2 over c into this equation. So 2 over c minus 8 is equal to 35. So 2 over c is equal to 43. Yeah, 43. So c is equal to 2 over 43. And the important thing for this question is to recognize that cx is equal to 2. And you can solve for x, plug it into this equation right here, and equate these two expressions. So, in other words, the general approach for this problem would be do 1, wait, cx is equal to 2, find fcx in terms find f2 in terms of c, and the third step is to equate. So yeah, so that's how you would do it. Now let's move on to question 3. So the cost of returning a large canopy tent for up to 10 days is $430 for the first day and $215 for each additional day. Which of the following equations gives the cost y in dollars of renting the tent for x days, where x is a positive integer and x is less than or equal to 10? So this question type is actually quite common. I've seen it a couple of times on the practice test, on the practice exams that College Blue Book gives out. So this is how you would approach it. So this is like the equation in the form of y is equal to mx plus b, right? So let's say that it's $215 for each additional day. So for the first day you have, so for the first day it's $430. And for the second to the 10th day, let's say, to the x day, where x is less than or equal to 10, the cost is $215. So essentially the slope would be $215. But you have to remember that it's for x minus 1 days, for which this is the case. And then the y, so if you have, so on the first day it would be $430, so you have to add back the $430. So essentially you have to think about it like this, right? Let's pretend that we start renting the house on the second day. Rent canopy tent on second day. Then the y-intercept would be, then the graph would be in the form of y is equal to 115x plus 430. But we have to remember that we're trying to count from the first day. So we have to do an x minus 1 instead of x, right? So we have to just essentially solve this equation. This is equal to 215x. You just distribute minus 215 plus 430. So this is equal to 215x plus 215. Yeah, so it's A. And if you want to check your answer, like literally just test for what if x is equal to 2, let's say. So you're on the second day. So it should be $430 for the first day plus $215 for the second day, which is $645. And if we plug it into this equation that x is equal to 2, we get 215 times 2 plus 215, which is equal to 430 plus 215, and this is equal to $645. So yeah, so 645 is equal to 645, so we know that A is correct. Which system of linear equations has no solution? Now remember what I said before, so this is essentially the same problem as the first problem here, because the first one asks you for infinitely many solutions, and the last one asks you for no solutions. And if a system of linear equations has no solutions in 2 dimensions, right? And this is obviously in 2 dimensions. You're not going to ask for anything in 3 dimensions, which is something different. So this is in 2 dimensions. So if a system of linear equations has no solutions in 2 dimensions, then the 2 lines have to be parallel. So their m must be the same. So their slope must be same. and their y-intercept b must be different. Because if their y-intercepts are the same, then they're like the same line, so there will be infinitely many solutions. So if there are no solutions, then their y-intercepts have to be different and their slopes must be the same. So let's check which one's the case right here. So for the first one, the slope is, if you rearrange, right, it's y is, so we put all of these in the slope intercept form. So it'd be y is equal to x minus 9 . And for the first one, we notice that they're literally the same line. So they're same, infinitely many solutions. So the A, you can just eliminate it. Let's try B. Okay, and from first glance, like, it's pretty obvious that these two slopes cannot be the same, right? Because, look, if you rearrange, y is equal to 2/3 x minus, minus 9 over 3, right? So, minus 9 over 3, and, this one, like, y is equal to negative. Like, we don't really care about the b's right here, so it's negative, 3 over 4. So, like, negative 3 over 4 is obviously not equal to 2/3. So, like, these two cannot, so B cannot have no solutions. Let's try D. Okay, so if you rearrange, then we have 2/3 x minus 3 is equal to y, and 2/3 x minus 3 is equal to y. So these are the same again. So let's try the fourth one. So this one. Oh wait. Yeah. So okay. So now let's try the fourth one. So this one's y is equal to negative. No, it's 3 over 2x. Plus 3. Now next one is y is equal to 2 over 3x minus 3. So the y-intercepts are not the same. What the first one is plus 3, the second one is minus 3. So D has to be the correct answer. Okay, so if x minus 5 equals over 7 equals to x minus 5 over 9, the value of x minus 5 is between which of the following pairs of values? Okay. So we just have to solve this equation, right? And we can solve this by cross multiplying. 9 times x minus 5 is equal to 7 times x minus 5. And what I wanted to notice here was that, like, you have x minus 5 on both sides. So you can actually do 9 times x minus 5 minus 7 times x minus 5 is equal to 0. So you know that 2 times x minus 5 has to be equal to 0. So you get that. So, and if you divide both sides by 2, right? Then x minus 5 has to be equal to 0. So x has to be equal to 5. So from, like, these choices, we know that C can be the only correct answer. So yeah, that's how you would approach it. And another way to do it is like put this equation to Desmos, and Desmos will give you x is equal to 5. So, like, Desmos will give you, like, 1, 2, 3, 4, 5. This is 5. And Desmos will give you, like, a line like this, right? So you won't know that when you put it into Desmos. So yeah. Yeah. So that's the end of this video. Thank you for watching, and please let me know if you'd like me to go over any other questions.